Good afternoon, class 10. I'll continue with the next part of the chapter, that is atomic nucleus. Last class, I think I finished till the chain reaction. So, we'll be doing the types of the chain fission reaction. Number one, controlled chain fission reaction. Controlled chain fission reaction. Now, what is it? Energy liberated in chain fission reaction is used in nuclear reactors to convert it to electricity. Now, why is it controlled? Why are we saying this reaction is controlled? It's because nuclear reactor consists of graphite and heavy water that absorbs some of the neutrons. Some of the neutrons means the neutrons that are liberated during the chain reaction. Absorb some of the neutrons, hence controls it. This is basically control chain fission reaction. Here the main thing is your use of nuclear reactors, which converts your energy to electricity, right? It is used in the nuclear power plants. And now how is it controlled? It consists of substances like graphite and heavy water that absorbs the neutrons that is liberated during the chain reaction, and so it controls the process. Okay, now the second one is uncontrolled chain fission reaction. Uncontrolled chain fission reaction. Now, why is it uncontrolled and what happens over here? So here the energy liberated in chain fission reaction is enormous. Enormous means very large. Okay, and is used in atom bombs. Now we know the impact of atom bombs, that is they are very harmful. Because we know these atom bombs were used during the Second World War in Hiroshima and Nagasaki, and it caused a huge scale destruction. It killed a number of people, the environment got affected. So atom bombs are actually harmful. Okay, but still it is used by our country for the defense purpose to protect us. Okay, so here it is uncontrolled. Why? Because here the neutrons which are liberated during the chain reaction, it cannot be absorbed. As a result of which the energy in each step is increasing, and then it is becoming enormous. So that energy is utilized in these atom bombs, which are causing a huge scale destruction. So this finishes the chain reaction type, which is basically under the nuclear fission reaction. Now comes your next type of nuclear reaction, that is nuclear fusion reaction. Nuclear fusion reaction. It is just the opposite of fission. Nuclear fusion. Now what is the meaning of fusion? Fusion means to combine together. Fusion means to combine. Now let's define. It is a process in which two lighter nuclei combine form a heavier nucleus at high temperature with release of large amount of energy. Okay, this is basically nuclear fusion is. Here the keywords: lighter nuclei combine to form a heavier nucleus, higher temperature, is very important, release of energy. Now why the energy is liberated, that we know, due to mass defect. That is the main reason of large amount of energy liberation. And why high temperature? Why high temperature? Now the reason behind this is high temperature. The reason I'm writing over here: when two nuclei approach means to come close to one another, approach each other, they suffer from repulsion. They suffer from repulsion. To overcome this, to overcome the repulsion, high temperature is required. To overcome the repulsion, high temperature is required. Okay, it is continued again from here. When two nuclei approach each other, they suffer from repulsion. To overcome the repulsion, high temperature is required. So here the reason is suffer from repulsion. Due to this, they need higher temperature to perform the reaction. Now let's see to the equation of nuclear fusion. H1, 3H1, we get plus left hand side the reactants are 2H1, 3H1. Right hand side we have helium, and this is your neutron, 1 neutron plus energy. Right? Here the mass number and atomic number is conserved. See, here it is 5. Here also it's 5. Atomic number it's 2. Here also it's 2. Right? And what are the applications? If I talk about the applications, what are they? So the first one is the energy liberated in fusion. Energy liberated in fusion reaction makes the sun and stars shine. Sun and stars shine. Second application, these are the application. Second one, it is used in hydrogen bombs. That is the energy liberated used in hydrogen bombs. These are the two applications. Now one point we just write. One point. This is not under application, a separate one. I am writing with a star only, but it is black star. It is separated from these two stars. Energy liberated during nuclear fusion is much more than the energy of nuclear fission. That is the energy liberated during nuclear fusion. Energy liberated during nuclear fusion is more than energy of nuclear fission. This is a point, right? Now we'll come to nuclear disaster. We have two famous nuclear disaster. Nuclear disaster. First one is Chernobyl disaster. Chernobyl disaster. It occurred in April 1986 in Chernobyl nuclear power plant. The nuclear reactor got exploded and caught fire. Okay, what were the effects? The incident killed a number of people and many were exposed to radiations. Many were exposed to radiations which had long-term effect. This is your Chernobyl disaster. It occurred in April 1986 in Chernobyl nuclear power plant, and the location was USSR. Okay, so this incident happened. The nuclear reactor got exploded and caught fire, and then it affected the people and the environment. Right. The second one is Fukushima disaster. Second one is Fukushima disaster. Fukushima disaster. Fukushima disaster. It occurred in March 2011 in Fukushima nuclear power plant in Japan. Okay, now what happened here? The nuclear reactor got affected due to tsunami. That was caused by an earthquake. This also killed number of people and exposed them to radiations. So this was your Fukushima disaster. So that's it, class 10. Thank you.